Tonight, we're diving into Viking navigation secrets that inspired GPS algorithms. Forget everything Hollywood told you. This is the real story. And trust me, you probably wouldn't last a day. So before you get too comfortable, hit that like button if you enjoy this kind of deep dive, and let me know in the comments where you're watching from. Now, dim the lights, maybe grab a snack, and let's jump in. You wake up on a Viking longship somewhere in the North Atlantic. The year is 950 AD. The smell hits you first: wet wool, tar, and about 30 unwashed men who haven't seen soap in weeks. Your smartphone? Dead. Google Maps? 800 years away. The only thing between you and becoming fish food is a piece of calcite crystal, some birds in cages, and the ability to read shadows that barely exist. Welcome to navigation before satellites, where one wrong turn means your entire crew becomes a cautionary tale sung by drunk Norsemen for centuries. Here's the thing, nobody tells you about Viking navigation. These guys weren't just randomly sailing west hoping to bump into land. They had a system so sophisticated that modern computer scientists literally studied it to improve GPS algorithms. I'm not making this up. Silicon Valley tech bros are sitting in their air-conditioned offices right now, using principles that Leif Erikson figured out while eating fermented shark meat and dodging icebergs. You're standing on the deck, and the captain hands you what looks like a wooden disc with notches carved around the edge. This is a bearing dial, and if you can't figure out how to use it, everyone dies. No pressure. The Vikings called it a Polaris, and it works like this. You hold it level, sight along the notches to known landmarks or celestial bodies, and calculate your position based on angles. Sounds simple, until you realize you're doing this while the ship is rocking like a mechanical bull at a Texas bar, salt spray is burning your eyes, and half the crew is seasick. But wait, it gets better. See that crystal the navigator is holding up to the cloudy sky? That's Iceland spar, a type of calcite that can detect the sun's position even through thick clouds. How? It polarizes light. When you look through it and rotate it just right, you can see a pattern that tells you exactly where the sun is hiding. Modern scientists tested this in 2011 and found it works with 90% accuracy. Vikings figured this out 1,000 years ago without understanding the physics of light polarization. They just knew it worked. Now here's where it connects to your GPS. Modern positioning algorithms use something called multilateration, calculating position based on distances from multiple known points. Vikings did the exact same thing, but instead of satellites, they used sun positions at different times of day, combined with dead reckoning and landmark navigation. They created mental maps with waypoints, just like your GPS creates a route with multiple nodes. The difference is they stored it all in their heads through stories and songs. Imagine memorizing every exit on a 1,000-mile highway, except the highway is the ocean and the exits are barely visible islands. The really mind-blowing part: Vikings used biological GPS too. Those cages I mentioned earlier full of ravens. When they thought land was near but couldn't see it, they'd release a raven. If it circled and came back, no land. If it flew off in a specific direction, that's where you sail. Ravens can sense land from over 100 miles away through electromagnetic fields and smell. Your GPS uses electromagnetic signals from satellites. Same principle, different technology. The Vikings just outsourced the computation to bird brains instead of silicon chips. Let me paint you a picture of what happens when this system fails. You're 3 weeks out from Norway, heading to Iceland. The Iceland spar is cracked. Your last raven died eating spoiled fish, and clouds have covered the sun for 4 straight days. Your navigator is doing something that looks like medieval calculus, scratching marks on a piece of wood while muttering about currents and wind patterns. This is dead reckoning, estimating position based on speed, time, and direction from your last known location. It's basically educated guessing with your life on the line. Here's what modern programmers learned from this. When GPS signals fail, your phone switches to inertial navigation, using accelerometers and gyroscopes to estimate movement from the last known position. Sound familiar? It's exactly what Vikings did, except they used wave patterns, wind consistency, and the flight paths of seabirds instead of sensors. They noticed that waves near land have different patterns than open ocean waves. They could literally feel their position through the ship's movement. Your phone does the same thing with its motion sensors when it loses satellite connection in a tunnel. You want to know something that will break your brain? Vikings navigated by smell. I'm serious. Different lands have distinct smells that carry on the wind. Iceland smells like sulfur from volcanic activity. Greenland has a crisp glacier smell. The Scottish islands smell like peat and sheep. Experienced navigators could smell land changes 40 miles out. Modern electronic noses in robots use the same principle for navigation in GPS-denied environments. The military is literally spending millions trying to replicate what some Viking could do after a night of heavy mead consumption. But the real genius wasn't any single technique, it was the redundancy. Vikings never relied on just one navigation method. Sunstone not working. Check the birds. Birds all dead. Read the waves. Waves too chaotic. Follow the whales. Everything failing. Start telling stories about landmarks and distances until something clicks. This multi-sensor fusion is exactly how modern GPS works. Your phone doesn't just use GPS satellites. It combines GPS, cell towers, Wi-Fi signals, Bluetooth beacons, barometric pressure, and magnetic fields. It's Viking navigation with more steps and less risk of scurvy. Now picture this scene. You're approaching the coast of North America 500 years before Columbus. Nobody in your crew has ever been here. There's no map, no guide, nothing. But your navigator starts recognizing patterns. The way clouds form over land versus water. The color changes in the sea that indicate depth and proximity to shore. The types of birds that only live near specific coastal environments. He's building a real-time map in his head, creating navigation algorithms on the fly. This is exactly what machine learning GPS systems do now. They learn patterns and improve their accuracy based on repeated observations. The Vikings even had a solution for night navigation that would make tech companies jealous. They used a combination of stars, particularly Polaris, and something called a shadow board. During the day, they'd mark shadows at specific times. At night, they'd use those measurements to maintain course by keeping Polaris at the same angle. It's basically celestial dead reckoning. Modern GPS satellites use atomic clocks to maintain precise timing for position calculations. Vikings used the sun and stars as their clock. Less precise, sure, but it didn't require a $20 billion satellite constellation either. Here's my favorite part. Vikings shared navigation data through oral tradition, encoding precise sailing directions in poems and sagas. These weren't just stories, they were compressed databases. Modern GPS systems compress map data the same way, using algorithms to reduce file size while maintaining accuracy. The Landmarbok, an Icelandic text, contains sailing directions so precise you can still follow them today. It's like someone encoded Google Maps directions into Shakespeare, and it actually works. Think about what this means for a second. Every time your Uber driver follows that little blue line on their phone, they're using principles that Vikings developed while most of Europe thought sailing out of sight of land meant falling off the edge of the world. The algorithm calculating your route, it's solving the same problems. Eric the Red solved, just faster, and without the constant threat of freezing to death. You know what's really wild? Vikings had their own version of GPS spoofing protection. Yeah, that thing where someone feeds false signals to mess with navigation systems. Vikings dealt with that too, except instead of hackers, they worried about enemy clans giving false directions to cause shipwrecks. So they developed verification methods. Multiple navigators would calculate position independently. They'd cross-reference celestial navigation with dead reckoning. They'd verify landmark descriptions against multiple sources. Sound familiar? It's exactly how modern GPS receivers detect and reject spoofed signals, through redundancy and cross-validation. Let me blow your mind with something else. Vikings understood relativity in navigation centuries before Einstein. They knew that position is relative to your reference frame. A bearing to Iceland from Norway is different than a bearing from Scotland. They adjusted their navigation based on starting position, just like GPS satellites adjust for relativistic effects caused by gravity and velocity. The Vikings didn't know why it worked. They just knew that navigation required adjusting for where you started and how fast you were moving. Here's where it gets really interesting for you computer science nerds watching. Viking navigation was essentially a distributed computing system. Each ship in a fleet would navigate independently, but they'd share information through signal fires, horn calls, and flag signals. If one navigator figured out the correct position, that information propagated through the fleet. It's exactly like how modern mesh networks share GPS data between devices to improve accuracy in challenging environments. The Vikings invented peer-to-peer navigation verification without knowing what a peer-to-peer network was. You're probably sitting there thinking this is all ancient history, but here's the kicker. The European Space Agency literally studied Viking navigation techniques when designing the Galileo satellite system. They wanted to understand how navigation worked without constant position updates, because satellites can fail. The Vikings' combination of environmental navigation, celestial positioning, and dead reckoning inspired backup protocols for when satellites go dark. So yeah, your GPS has a Viking mode built in for emergencies. The craziest part, Vikings solved the traveling salesman problem without computers. They had to figure out the most efficient route between multiple destinations considering currents, weather patterns, and seasonal variations. They created optimal paths through trial and error, encoding successful routes in their sagas. Modern route optimization algorithms solve the same problem, just with more variables and less risk of death by exposure. But the core challenge, finding the shortest path between multiple points, remains unchanged. Comment below if you've ever gotten lost even with GPS. Because here's the truth that nobody wants to admit. All our satellite technology, all our algorithms, all our precision timing, it's making us worse navigators than Vikings were. They could read the world like a book. We can barely find our car in a parking lot without electronic help. Those berserkers would probably laugh at us right before offering to teach us how to navigate by watching which way birds fly at sunset. So next time your GPS recalculates for the 5th time, remember that some Viking probably made the same journey using nothing but a crystal, some birds, and an uncomfortable amount of confidence. The technology changed, but the problem didn't. We're all just trying to figure out where we are and where we're going, whether we're using satellites or sunstones to do it. You think you understand navigation? Cool. It's dawn on your Viking ship, and the navigator just died of dysentery. Congratulations, you're promoted. Your first task is to figure out where the hell you are using something called latitude sailing. No, you can't Google it. You can't even spell Google in Old Norse. What you can do is measure the sun's height at noon, using a stick and some basic geometry that would make your high school math teacher weep with joy. Here's how latitude sailing worked. And pay attention because this is where GPS got its basic framework. Vikings would sail north or south to reach the latitude of their destination, then turn and sail east or west along that invisible line until they hit land. It's like navigating a grid where you can only see one axis at a time. They measured latitude by the sun's angle at noon, or Polaris's height at night. No fancy tools, just a straight stick, and the ability to estimate angles like your life depended on it, because it literally did. Modern GPS uses a similar grid system called WGS-84, which divides Earth into a coordinate system. The difference: GPS can see all axes simultaneously using satellite triangulation. Vikings had to navigate one dimension at a time, like playing three-dimensional chess when you can only see one board. They'd sail to 61 degrees north, the latitude of Bergen, Norway, then head west knowing they'd eventually hit Greenland. It's brilliant in its simplicity and terrifying in its margin for error. But here's what nobody talks about. Vikings discovered something computer scientists wouldn't formalize until the 1970s: fuzzy logic. They didn't need exact positions. They needed good enough positions with probability ranges. Is that landmass probably Iceland? Are we probably north of our target? This probabilistic navigation is exactly how modern GPS handles uncertainty. When your phone says accuracy within 5 meters, it's using the same fuzzy logic Vikings used when they said, "We're probably a day's sail from land, give or take a storm." You want to know what's really messed up? Vikings navigated through the Arctic without compasses because compasses don't work properly that far north. Magnetic declination near the poles makes compasses spin like a drunk ballerina. So they used something called a bearing dial combined with sun shadows. They'd mark shadow positions at known times, creating a solar compass that worked regardless of magnetic interference. The US military studied this technique for polar navigation before GPS existed. Those Pentagon strategists were literally reading Viking sagas for navigation tips. Now you're standing on deck trying to use this bearing dial, and you realize something horrifying. The sun barely rises in winter this far north. You get maybe 4 hours of usable daylight, and it's so low on the horizon that shadows are almost horizontal. This is where Vikings got creative with something that would later inspire differential GPS. They used relative positioning between multiple reference points. Can't see the sun? Use the moon. Can't see the moon? Use the brightest stars. Can't see stars? Use the aurora borealis, which actually follows predictable patterns based on solar wind interaction with Earth's magnetosphere. Let me tell you about something called the Vikings navigation paradox that computer scientists love. The more accurate your navigation needs to be, the less accurate your tools can be. Vikings navigating across thousands of miles of ocean could be off by 50 miles and still hit their target. But navigating through narrow fjords required precision within meters. So they developed different navigation modes for different scales, exactly like how your GPS switches between road navigation and walking navigation. The algorithms adjust precision based on speed and scale, a concept Vikings figured out through pure trial and error. You're 2 weeks into your journey now, and something interesting happens. The water changes color from deep blue to greenish gray. Congratulations. You've just discovered submarine navigation without sonar. Vikings could read underwater topography by watercolor, wave patterns, and current behavior. Continental shelves, underwater mountains, and deep trenches all create distinct surface patterns. This is exactly how modern bathymetric satellites map the ocean floor, by reading surface variations caused by underwater features. But Vikings took it further. They noticed that different water temperatures create different fog patterns. Cold currents meeting warm air create specific fog banks that act like navigation markers. The East Greenland current creates a fog wall that Vikings used as a western boundary marker. Modern weather satellites use the same temperature differential patterns for ocean current mapping. The Vikings just did it with their faces, instead of infrared sensors. Here's something that'll mess with your head. Vikings navigated by sound. Different coastlines create different echo patterns. Cliffs sound different than beaches. Foes create acoustic channels that carry sound for miles. Ice makes distinctive cracking sounds that indicate thickness and movement patterns. They built a three-dimensional sound map of coastlines. The US Navy later developed similar acoustic navigation for submarines, but Vikings were doing it first with just their ears and the occasional horn blast. You know what's absolutely insane? Vikings figured out great circle navigation without understanding that Earth is a sphere. They noticed that the shortest route between 2 points wasn't always a straight line on their mental maps. Sailing from Norway to Greenland, the optimal path curves north, following Earth's curvature. They didn't know why it worked. They just knew it saved time. Modern GPS calculates great circle routes using spherical trigonometry. Vikings did it through generational trial and error, encoding optimal paths in sailing songs. Now let's talk about something called navigation drift that both Vikings and GPS have to deal with. Every measurement has error. Every calculation compounds that error. Over time, small mistakes become massive problems. Vikings solved this with regular position resets using known landmarks. They'd deliberately sail to recognizable points to recalibrate their mental position. GPS does the exact same thing with ground-based augmentation systems. Those cell towers your phone pings, they're serving the same function as a Viking, recognizing a distinctive mountain, providing a known reference point to reset accumulated error. The social aspect of Viking navigation inspired modern crowdsourced GPS improvements. Vikings would gather in halls during winter to share navigation discoveries. Someone found a new current. Everyone learns about it. Someone discovered a better route. It becomes common knowledge. This collective intelligence gathering is exactly how apps like Waze work. Millions of users sharing real-time navigation data to improve everyone's journey. The only difference is Vikings did it with mead and storytelling instead of smartphones and algorithms. But here's the really clever bit. Vikings developed what we now call waypoint navigation. Instead of trying to sail directly from Norway to North America, they'd hop between known points. Norway to Shetland, to Faroe, to Iceland, to Greenland, to Vinland. Each leg was manageable, with known distances and conditions. Your GPS does the same thing, breaking long routes into segments between waypoints. The algorithm is identical, minimize risk by maximizing known positions. Vikings just called them stepping stones instead of nodes in a navigation graph. Time for an uncomfortable truth. You're realizing that Viking navigation wasn't just about finding land, it was about finding it at the right time. Arriving in Greenland in winter meant death. Arriving during storm season meant shipwreck. Vikings had to navigate through both space and time, calculating not just where to go but when to arrive. This temporal navigation is exactly what modern GPS routing algorithms do when they account for traffic patterns. Your phone suggesting you leave at 3 p.m. to avoid rush hour. That's Viking seasonal navigation logic with a Silicon Valley paint job. Let me tell you about the most underappreciated Viking navigation tool, human memory. These people memorized thousands of miles of coastline, hundreds of navigation markers, and dozens of seasonal variations. No written charts, no backup files, just pure mental storage. They used a technique called the method of loci, associating navigation information with familiar locations in mental spaces. Modern memory athletes use the exact same technique. But here's the kicker. Computer scientists studied these memory techniques to develop cache algorithms for GPS systems. The way your phone stores frequently used map data, inspired by how Vikings organized navigation information in their minds. You're probably wondering how Vikings handled navigation conflicts. Two navigators disagree on position. Three different sun readings give three different latitudes. Welcome to Byzantine fault tolerance, a concept computer scientists formalized in 1982 that Vikings practiced in 982. They used consensus mechanisms. Multiple navigators would independently calculate position, and they'd go with the majority opinion. If someone consistently gave bad readings, they'd be excluded from future calculations. It's exactly how modern GPS receivers handle multiple satellite signals with varying quality. They vote on the most likely position based on signal consensus. Here's something that'll make you appreciate your GPS even more. Vikings had to account for magnetic declination without knowing magnetism existed. They noticed that sun directions and star directions didn't always align perfectly. The angle changed based on location. They called it the sun's disagreement and adjusted for it through experience. Modern GPS systems correct for magnetic declination automatically, but the problem remains the same. True north and magnetic north are different, and the difference changes based on where you are. Now for the mind-blowing part. Vikings inadvertently discovered network effects in navigation. The more ships that sailed a route, the better the navigation became, not just through shared knowledge, but through physical markers. Ships would leave cairns on islands, carved marks on cliffs, and even alter landscapes to create navigation aids. Each journey improved the route for the next traveler. This is exactly how modern GPS maps improve through usage. Every phone traveling a route provides data that refines the navigation algorithm. Vikings created physical breadcrumbs. We create digital ones. You want to know what's really wild? Vikings understood signal degradation centuries before radio was invented. They knew that navigation information degraded with each retelling. Details got fuzzy, distances got exaggerated, dangers got mythologized, so they developed error correction through redundant encoding. Important navigation information appeared in multiple sagas, songs and stories. If one version got corrupted, others preserved the truth. Modern GPS uses similar error correction codes to ensure signal integrity. The Vikings just did it with poetry instead of parity bits. Drop a comment if you've ever ignored your GPS and taken your own route, because that's exactly what made Viking navigation work. The ability to override systematic navigation with human intuition. They knew when to trust their instruments and when to trust their gut. Modern autonomous systems are just now learning this balance through machine learning. Tesla's autopilot learning when to break rules. Vikings were doing that 1,000 years ago, except their autopilot was a grizzled navigator who could smell storms 3 days out. Alright, we need to talk about the birds. Not in a romantic way, but in a your life depends on understanding avian navigation patterns way. You're below deck, and you hear the navigator shouting orders to bring up the ravens. These aren't pets. They're biological navigation computers with wings, and they're about to do something that would make Silicon Valley engineers weep with envy. Ravens can detect magnetic fields, infrared radiation, and ultrasonic frequencies. They process this information through a brain the size of a walnut to create navigation solutions that supercomputers struggle to replicate. When Vikings released a Raven, they weren't just hoping it would find land, they were deploying a sensor package that could detect electromagnetic anomalies, atmospheric pressure changes, and chemical gradients invisible to human senses. The bird would spiral upward, scanning in expanding circles, processing millions of data points to determine the most likely direction of land. Modern drone navigation uses similar spiral search patterns for lost signal reacquisition. When a drone loses GPS, it climbs altitude while circling to re-establish connection. Vikings figured this out by watching ravens. The birds naturally climb to increase their sensor range, using altitude to extend their detection horizon. Computer scientists studied this behavior to develop search algorithms for autonomous vehicles, that delivery drone bringing your package. It's using Raven-inspired navigation protocols, but here's where it gets absolutely insane. Ravens don't just fly to land, they fly to the best land. They can differentiate between a barren rock and a habitable island from 60 miles away. How? They detect biological signatures. Living ecosystems emit different chemical and electromagnetic patterns than dead rock. Vikings noticed ravens would ignore certain islands while flying toward others. They were essentially using biological remote sensing centuries before satellites could detect vegetation through spectral analysis. You're watching this raven circle your ship, and you notice something odd. It's not flying straight up. It's following an invisible spiral staircase, riding thermal columns that you can't see or feel. Vikings learned to read these flight patterns like a map. Tight spirals meant strong thermals, indicating land-generated heat. Wide circles meant ocean thermals, suggesting open water. This is exactly how modern soaring algorithms work for long-endurance drones. They use the same thermal detection and exploitation strategies that ravens perfected through millions of years of evolution. Now here's the part that breaks my brain. Ravens can navigate using quantum entanglement in their eyes. I'm not making this up. They have proteins called cryptochromes that create entangled electron pairs. These quantum pairs act like a biological compass, letting ravens see magnetic fields as visual overlays. Vikings had access to quantum navigation technology. They just didn't know the physics behind it. Modern quantum GPS systems being developed for submarine navigation. They're trying to replicate what a raven does naturally. But Vikings didn't just use ravens. They had an entire avian navigation suite. Seagulls indicated proximity to land, but not direction. They follow ships hoping for food, creating false positives. Puffins meant you were within 20 miles of their nesting grounds. Arctic terns indicated seasonal patterns and current directions. Each bird species provided different navigation data. It's like having multiple sensor types on a modern aircraft radar, lidar, infrared, each giving different information that combines into a complete picture. Let's talk about something Vikings called wave wisdom that makes modern oceanographers jealous. You're standing on deck, feeling the ship move, and the navigator is doing something that looks like meditation. He's not praying, he's reading wave refraction patterns through his feet. When ocean swells hit underwater obstacles or coastlines, they bend and reflect in predictable ways. Vikings could feel these patterns through ship movement and determine the direction and distance to land. This is exactly how modern wave radar works. Satellites bounce signals off ocean surfaces and analyze the return patterns to detect underwater features and coastal positions. Vikings did the same thing using their bodies as sensors. They could distinguish between wind waves on the surface and deep ocean swells from thousands of miles away. They knew that swells from the Atlantic had different periods than swells from the Arctic Ocean. By feeling the interference patterns where different wave systems met, they could triangulate their position. But here's the really clever part. Vikings discovered that waves behave differently at night due to temperature changes. Cooling air creates different wind patterns, which generate distinct wave signatures. They could navigate by the changing feel of waves as day turned to night. Modern autonomous ships use similar temporal pattern recognition to navigate without GPS. They measure how environmental conditions change over time to determine position and heading. The Vikings just did it through their feet instead of accelerometers. You know what's absolutely wild? Vikings could navigate by reading the foam patterns on wave crests. Different wind speeds and directions create specific foam distributions. Fresh foam means active wind. Aged foam indicates wind from hours ago. The direction of foam streaks shows wind history. By reading these patterns, Vikings could reconstruct weather patterns from the past day and predict future conditions. Modern weather routing algorithms for shipping use the same historical pattern analysis. They just use satellite data instead of eyeballs. Now for something that sounds like fantasy, but is absolutely real. Vikings navigated by phosphorescence. Certain plankton emit light when disturbed. Ship wakes would glow in patterns that indicated water temperature, salinity, and biological activity. Different regions had different phosphorescent signatures. The Mediterranean had one pattern, the Atlantic another, the Arctic yet another. Vikings could literally see their location in the glowing water. Modern bioluminescence mapping uses the same principle for naval navigation in GPS. Denied environments. Here's where Viking navigation gets prophetic. They understood that navigation isn't just about position, it's about prediction. They tracked whale migrations, knowing that certain species followed specific routes at specific times. Following whales meant following food sources, which meant following currents, which meant predictable navigation paths. Modern predictive navigation algorithms use the same logic, your GPS suggesting alternate routes based on typical traffic patterns. That's whale following logic applied to cars. The Vikings even figured out something called navigation by absence. Sometimes what you don't see is more important than what you do. No birds means you're in the deep ocean. No kelp means you're far from shallow waters. No ice means you're south of certain latitudes. They navigated by negative space, using missing information to constrain position possibilities. Modern Bayesian navigation filters use the exact same principle, eliminating impossible positions based on absent sensor data. Time to talk about the most metal navigation technique ever developed. Vikings navigated by death. I'm serious. They tracked floating corpses, dead whales, and shipwrecks to understand current patterns. A body floating from a known shipwreck provided information about current speed and direction. Morbid? Absolutely. Effective? Incredibly. Modern ocean current models use the same principle with floating buoys instead of bodies. The physics is identical. Track floating objects to map water movement. You're probably thinking I'm exaggerating, but Vikings took this further. They noticed that different materials decomposed at different rates in seawater. Wood from different trees lasted different amounts of time. By examining floating debris, they could estimate how long it had been in the water, and therefore how far it had traveled. This is exactly how modern marine forensics works. Those containers that fall off cargo ships, scientists track them to understand ocean currents. Vikings were doing maritime CSI 1,000 years early, but here's the genius part. Vikings created intentional navigation markers by throwing specific items overboard at known locations. Carved wooden floats with runic markings would drift with currents, creating a readable pattern for following ships. If you found a marked float, you knew which current you were in, and approximately when the previous ship passed. It's basically ancient AIS, automatic identification system transponders, except powered by currents instead of electronics. Let me blow your mind with something else. Vikings navigated by sound refraction in water. Sound travels differently through water layers of different temperatures and densities. By dropping weighted lines and listening to the echo patterns, they could determine water depth and bottom composition. Sand sounds different than rock. Mud sounds different than gravel. They built acoustic maps of the seafloor. Modern sonar uses the exact same principle, just with electronic speakers instead of rocks on strings. You want to know something that makes modern engineers embarrassed? Vikings solved the multiple path problem in navigation. When signals, whether sound or sight, bounce off multiple surfaces, they create confusion. Is that echo from the cliff ahead or the iceberg to starboard? Vikings developed protocols for disambiguating reflected signals. They'd change position and re-observe, using the difference to triangulate true positions. This is exactly how GPS receivers handle multipath errors in urban canyons. Those tall buildings bouncing signals. Vikings dealt with the same problem with cliffs and icebergs. Here's the part that really gets me. Vikings understood that navigation is probabilistic, not deterministic. They didn't navigate to exact points. They navigated to probability zones. Their sagas don't say sail to exactly here. They say sail until you see this. Then look for that, and you'll probably find what you're seeking. This probabilistic thinking is fundamental to modern Kalman filters used in GPS. The filter doesn't calculate exact position. It calculates the most probable position given noisy sensor data. Comment below if you've ever trusted your GPS into a lake or dead end, because Vikings had a solution for that too: navigation verification through impossible results. If their calculations said they should be on land but they were clearly at sea, they didn't blindly trust the navigation. They'd stop, reassess, and figure out where the error occurred. Modern GPS integrity monitoring does the same thing. If the calculated position is impossible given physical constraints, the system flags an error. Vikings called it common sense. We call it RAIM, Receiver Autonomous Integrity Monitoring. Same concept, fancier acronym. You've been at sea for 3 weeks now, and food is running low. The navigator makes a decision that seems insane. He's going to navigate by hunger. Not his hunger, but the hunger of the sea itself. Vikings discovered that ocean productivity follows predictable patterns. Where cold currents meet warm waters, nutrients rise from the deep, creating feeding grounds that attract everything from plankton to whales. Find the food, find the current, find the current, find your position. This biological navigation is more sophisticated than you'd think. Vikings knew that different species fed at different depths and temperatures. Seeing certain fish meant specific water conditions. Mackerel indicated warm surface currents from the south. Cod meant cold bottom water from the north. Herring schools moved in predictable patterns based on temperature gradients. They were essentially using fish as living thermometers and current meters. Modern fishery satellites track the exact same biological indicators to map ocean conditions. The Vikings just did it with fishing lines instead of spectral sensors. But here's where it gets really interesting. Vikings noticed that seabirds followed specific feeding patterns based on time of day and season. Morning flights headed toward feeding grounds. Evening flights returned to roosts. By tracking bird commutes, Vikings could determine the direction to land even when they couldn't see it. This is exactly how modern radio direction finding works. Track signal sources to determine bearing. Vikings were doing radio navigation without radios, using birds as biological transmitters. You're watching the water, and suddenly it changes from clear blue to murky green. The navigator gets excited. You've hit a plankton bloom, which means you're in an upwelling zone where deep ocean water rises to the surface. These zones occur in predictable locations based on underwater topography and current patterns. Vikings used these biological signposts as navigation markers. Modern satellite navigation systems use ocean color sensors to detect the same plankton blooms for maritime routing. The Vikings just used their eyes instead of multispectral images. Now for the really weird part. Vikings navigated by whale songs. Different whale species have different calls that travel different distances underwater. Blue whale calls can travel thousands of miles. Humpback songs have distinct regional dialects. By listening to whale vocalizations, either directly or through ship hull vibrations, Vikings could determine which populations they were near and therefore their approximate position. The US Navy later developed similar passive sonar techniques for submarine navigation. Those attack subs tracking targets by sound. They're using whale-inspired navigation that Vikings discovered first, But Vikings took biological navigation even further. They knew that certain parasites only existed in specific waters. Ships that sailed through tropical waters would get different barnacle species than those in Arctic waters. By examining hull growth, they could determine where a ship had been. It's like biological GPS logging. Modern environmental DNA sampling uses the same principle, tracking organism presence to determine location history. The Vikings were doing eDNA analysis with scrapers and eyeballs instead of gene sequences. Here's something that'll make you appreciate the complexity of Viking navigation. They had to account for biological seasons that didn't match calendar seasons. Fish migrations, bird nesting, and whale movements all followed different cycles. A navigator had to keep track of multiple biological calendars simultaneously. Miss the herring run, and you'd miss a critical navigation marker. This multi-temporal navigation is exactly what modern precision agriculture GPS systems do, tracking multiple seasonal cycles to optimize positioning and timing. Let's talk about something Vikings called the green flash. That sounds like mythology, but is actually advanced atmospheric optics. At sunset, under specific conditions, the sun briefly flashes green as it disappears below the horizon. This phenomenon occurs when atmospheric layers refract different wavelengths of light at different angles. Vikings used this to determine atmospheric conditions and therefore weather patterns. Seeing the green flash meant stable air and good sailing ahead. No flash meant turbulent air and storms coming. Modern atmospheric GPS correction models use the same atmospheric refraction principles. GPS signals bend as they pass through different atmospheric layers, creating position errors. By measuring the refraction at different frequencies, receivers can calculate atmospheric conditions and correct for signal bending. Vikings were essentially doing atmospheric tomography with their eyeballs, using the sun as their signal source instead of satellites. But here's the really clever part. Vikings noticed that the green flash appeared at slightly different times depending on your elevation. A lookout at the masthead would see it seconds after someone on deck. By timing this difference, they could calculate their exact eye height above water, which helped determine ship loading and stability. This is the same principle GPS uses for precise elevation measurement, timing signals from different angles to determine height. The Vikings just used sunset instead of satellites. You're standing watch at dawn and you see something impossible. The sun rises twice. It peaks above the horizon, disappears, then rises again. This is the Novaya Zemlya effect, caused by extreme atmospheric ducting that bends light around Earth's curvature. Vikings used these optical anomalies as navigation markers. Certain atmospheric conditions only occurred in specific locations at specific times of year. Seeing a double sunrise in winter meant you were in the Arctic temperature inversion zone. Modern over-the-horizon radar uses the same atmospheric ducting to see beyond Earth's curvature. Vikings were doing beyond visual range navigation using atmospheric physics they didn't understand. Now for something that sounds like magic, but is pure science. Vikings navigated by ice songs. Different types of ice make different sounds. New sea ice tinkles like breaking glass. Old pressure ridges groan like giant doors. Icebergs pop and crack in patterns that indicate their internal stress. By listening to ice music, Vikings could navigate through frozen seas in total darkness. Modern ice navigation systems use acoustic signatures for the same purpose. Those nuclear subs navigating under Arctic ice. They're using Viking ice reading techniques enhanced with hydrophones. Here's where Viking atmospheric navigation gets prophetic. They discovered that certain cloud formations preceded land by specific distances. Lenticular clouds formed over mountains even when the mountains were beyond the horizon. The clouds acted like navigation beacons floating in the sky. Modern satellite navigation ground stations use similar atmospheric markers to calibrate signal propagation models, those weird clouds you see. Vikings knew they were nature's navigation aids, but the most impressive atmospheric navigation technique was reading the color of the sky's reflection on clouds. Clouds over ice appear white underneath. Clouds over water look dark. Clouds over land show a greenish tint. Vikings called this the land sky and water sky. By reading cloud bottom colors, they could map surface conditions beyond visual range. Modern hyperspectral imaging satellites use the exact same principle, analyzing reflected light to determine surface composition. Vikings were doing remote sensing with their naked eyes. Time for the navigation technique that Vikings kept so secret. It almost disappeared from history. Reading the underwater sky. On calm days, the sea surface acts like a mirror, reflecting and refracting light in ways that reveal underwater topography. Deep water appears dark blue. Shallow banks show turquoise. Underwater ridges create light ribbons on the surface. Vikings could read the sea floor like a map painted in shades of blue. This optical bathymetry is now a cornerstone of satellite ocean mapping. Modern systems use LiDAR and multispectral imaging to map seafloor features through water. But here's the kicker. Vikings did it better in some ways. They could read subtle color changes that satellites miss because they observed from multiple angles as the ship moved. They built three-dimensional mental models of underwater terrain by integrating observations over time. Modern structure from motion algorithms do the same thing, building 3D models from multiple 2D images. Vikings were doing photogrammetry in their heads. You want to know something that'll make you question everything? Vikings navigated by the taste of the air. Different regions have distinct atmospheric chemistry. Sea spray near volcanic islands tastes metallic. Arctic air has a sharp, clean taste. Tropical air feels thick and sweet. Experienced navigators could identify their region by breathing deeply. Modern electronic noses in spacecraft use the same principle for life support monitoring. Those air quality sensors in your car, they're doing what Viking navigators did with their tongues and noses. But here's the absolutely insane part. Vikings discovered that human bodies are electromagnetic sensors. They noticed that sailors would feel uneasy before magnetic storms. Joints would ache before pressure changes. Some navigators claimed they could feel direction like an internal pull. Modern science confirms that humans have magnetoreceptors, though most of us can't consciously access them. Vikings selected navigators partly based on their sensitivity to these signals. They were essentially choosing people with biological compass abilities. Let me tell you about Viking navigation by dreams. I know it sounds crazy, but hear me out. During long voyages, navigators would pay attention to crew dreams and visions, not for mystical reasons, but because the brain processes subtle environmental cues during sleep. Consistent dreams about specific animals or landscapes often preceded actual encounters. The subconscious was detecting patterns the conscious mind missed. Modern sleep research shows that the brain continues processing sensory information during REM sleep, sometimes solving problems that stumped the waking mind. Vikings were using distributed subconscious processing for navigation. Here's something that connects directly to modern augmented reality navigation. Vikings used mental overlays to navigate. They'd imagine grid lines on the sea, visualize past routes as glowing paths, and project future positions based on current conditions. They called it the sight, and navigators trained for years to develop it. This mental augmentation is exactly what AR navigation apps do now, overlaying digital information on physical reality. Vikings were doing AR navigation using imagination instead of smartphones. Drop a comment about the weirdest thing your GPS has ever done. Because Viking navigation reminds us that technology isn't always the answer. Sometimes the best navigation system is pattern recognition developed over generations. Vikings encoded centuries of observation into their culture, creating a collective navigation intelligence that no individual could match. Modern machine learning tries to replicate this by training on massive datasets. But Vikings did it through storytelling, turning navigation into culture. Your GPS might get you there faster, but it'll never tell you a saga about the journey. Buckle up, because we're about to dive into the Viking navigation technique that literally broke historians' brains when they figured it out. The sun compass that works in the dark. You're below deck during a storm, haven't seen the sun in 4 days, and the navigator pulls out a wooden disc that looks like a kindergarten craft project. But this thing is about to do something. Your smartphone can't determine true north using shadows that don't exist. The device is called a solar stin shadow board, and it works on principles so advanced that MIT researchers are still writing papers about it. Vikings discovered that even on completely overcast days, sunlight remains partially polarized. The human eye can't detect this, but when you combine a shadow board with Iceland spar crystal, you can determine the sun's position with accuracy that rivals modern instruments. The board has concentric circles and radial lines. You place a vertical fancy word for stick in the center, rotate the crystal until you see the polarization pattern, and boom, you know where the sun is, even though you can't see it. But here's where it gets absolutely mental. Vikings figured out how to use this system at night by referencing shadow positions from earlier in the day. They'd mark shadow angles at specific times, then use those marks to maintain heading after dark. It's essentially dead reckoning, using the sun's predicted path. Modern GPS satellites use similar ephemeris data, predetermined orbital positions to calculate location. Vikings were doing celestial mechanics with sticks and string. You know what's really going to bake your noodle? This shadow board could compensate for the ship's movement. The navigator would adjust the angle based on the ship's roll and pitch, keeping it perpendicular to the true horizon, not the deck. They were essentially creating a stabilized platform, using human reflexes. Modern ships use gyroscopic stabilization for navigation equipment. Vikings used their inner ear and muscle memory. Same result, different technology. Now for the part that makes quantum physicists excited. The Iceland spar crystal Vikings used exhibits birefringence. It splits light into 2 polarized beams. When you look through it at the sky and rotate it, you see a pattern that reveals the sun's position. This works because atmospheric scattering creates predictable polarization patterns centered on the sun. Vikings were using quantum optical properties of crystals for navigation 1,000 years before anyone understood what photons were. But Vikings didn't stop there. They discovered that different crystals worked better at different times of day and weather conditions. Calcite for overcast days, cordite for twilight, tourmaline for specific sun angles. They built a toolkit of optical instruments, each optimized for different scenarios. This is exactly how modern GPS receivers use different signal processing algorithms for different conditions. Clear sky, use high precision mode. Urban canyon, switch to multipath mitigation. Vikings were doing adaptive signal processing with rocks. Here's something that'll make you appreciate Viking innovation. They figured out how to calibrate these instruments using the moon and stars. On clear nights, they'd use known celestial positions to verify and adjust their shadow boards. If the moon shadow didn't match predictions, they knew their instrument needed recalibration. Modern GPS ground stations do continuous calibration, using known positions. Vikings were doing the same thing, just with more manual labor and less automation. Let's talk about the Viking navigation computer that archaeologists found and couldn't believe was real. The Acoustic disc. This wooden disc, about the size of your palm, has notches and marks that look random until you realize it's a hyperbolic navigation calculator. Vikings were doing trigonometry without knowing trigonometry existed. Here's how it worked. The disk has curves that represent the sun's path at different times of year. By aligning these curves with shadow observations, navigators could determine both latitude and time of day. But the really clever part, the curves account for atmospheric refraction, the bending of light that makes the sun appear higher than it actually is. Vikings empirically discovered and corrected for an optical phenomenon that wouldn't be formally described until the 1600s. You're standing there trying to use this thing, and you realize something disturbing. It's personalized. Each navigator would modify their disk based on their height, their ship, and their typical routes. These weren't mass-produced instruments. They were custom navigation computers, calibrated through years of use. It's like having a machine learning algorithm that trains specifically on your data. Modern personalized navigation apps are just now catching up to what Vikings did with carved wood. But here's the mind-blowing part. These disks could predict eclipses. By tracking shadow patterns over months, Vikings noticed cycles that corresponded to lunar and solar eclipses. They couldn't explain the astronomy, but they could predict when navigation would be affected. Imagine sailing across the Atlantic and knowing that in 3 days your sun compass won't work for 2 hours. That's the level of environmental awareness Vikings achieved through pure observation. Now for something that makes computer scientists jealous. Vikings encoded navigation algorithms directly into physical objects. The curves on navigation disks aren't arbitrary, they're geometric solutions to navigation equations. Instead of calculating, navigators just aligned marks and read results. It's analog computing at its finest. Modern slide rules work on the same principle, but Vikings were doing it for spherical trigonometry, not simple multiplication. The social aspect of these instruments is fascinating. Navigation disks were passed down through families, each generation adding refinements, corrections for newly discovered currents, marks for additional ports, notes about seasonal variations. These disks became multi-generational databases, encoding centuries of navigation knowledge in a piece of wood the size of a coffee cup coaster. Modern open-source software development follows the same pattern, continuous improvement through community contribution. Here's where Viking navigation instruments get prophetic. They built redundancy into single devices. A navigation disk could function as a sun compass, a latitude calculator, a tide predictor, and a calendar. If one function failed, others still worked. This graceful degradation is a cornerstone of modern fault-tolerant systems. Your phone's GPS fails, it switches to cell tower triangulation. Vikings built the same failover mechanisms into their wooden computers. Time for the navigation technique that Vikings used but never talked about, reading the magnetic signatures of land. Long before anyone understood magnetism, Vikings noticed that certain rocks made iron objects behave strangely. They didn't know about magnetic fields, but they knew that sailing near certain islands made their iron tools point in consistent directions. Volcanic islands like Iceland have strong magnetic anomalies from iron-rich basalt. These anomalies extend underwater, creating magnetic navigation channels that Vikings could follow using suspended iron needles or naturally magnetic lodestones. They were essentially doing magnetic surveying centuries before compasses were invented. Modern aeromagnetic surveys used the same principle to map geological features. Vikings were doing it with fishing weights and sword blades. But here's the really clever part. Vikings noticed that magnetic effects changed with temperature. Cold iron responded differently than warm iron. Morning readings differed from afternoon readings. They didn't understand thermal effects on magnetism, but they developed protocols to account for them. Always test at the same time of day. Always use iron at the same temperature. These standardization procedures are exactly what modern magnetic observatories use to ensure consistent measurements. You want to know something that'll mess with your head. Vikings navigated by the aurora borealis, not just as a general north indicator, but as a precise navigation tool. They noticed that aurora patterns followed predictable paths based on magnetic conditions. Certain displays only occurred at specific latitudes. The colors indicated different atmospheric conditions. By reading aurora patterns, Vikings could determine their position within a few degrees of latitude. Modern space weather monitoring does the same thing, using aurora observations to map magnetic field interactions. Now for the absolutely insane part. Vikings discovered that certain people could sense magnetic fields better than others. They called them iron-minded and selected them as navigators. Modern research confirms that some humans have stronger magnetic sensitivity, possibly due to magnetite crystals in their brains. Vikings were selecting for a genetic trait that enhanced navigation ability. It's selective breeding for biological GPS sensitivity. Here's where Viking magnetic navigation connects to modern technology. They discovered that magnetic readings were more accurate at certain times of day, specifically dawn and dusk. Earth's magnetic field fluctuates daily due to solar-wind interaction. The quietest times are around sunrise and sunset. Modern magnetic surveys schedule measurements during these magnetic quiet times. Vikings figured this out through trial and error, noticing that dawn readings were more consistent than midday ones. But the most impressive part, Vikings created magnetic maps without knowing what magnetism was. They noticed that certain routes had consistent iron-pointing behaviors. Sail from Norway to Iceland, and your iron points slightly left at this island, slightly right at that reef. They encoded these magnetic bearings in their sagas, creating verbal magnetic charts. Modern magnetic navigation charts show the same information, magnetic declination at different positions. Vikings were doing magnetic cartography with poetry. Comment below if you've ever had your phone compass go crazy near certain objects or places, because Vikings dealt with the same problem and solved it through protocol. Never trust iron near the volcanic islands. Always verify with sun sightings after sailing through magnetic rocks. These verification procedures are exactly what modern avionics use, multiple independent systems cross-checking each other. Vikings invented navigation redundancy because they learned the hard way that single points of failure mean death at sea. Time to talk about the most badass Viking navigation achievement that nobody appreciates: sailing through fog so thick you couldn't see the front of your own ship. You're in the North Atlantic, visibility is zero, and the navigator is doing something that looks like meditation but is actually echolocation. He's banging a drum and listening to the echoes, building a sound map of invisible obstacles. Vikings discovered that different materials reflect sound differently. Ice sounds bright and sharp. Rock cliffs sound deep and hollow. Sandy beaches absorb sound, creating dead zones. By making controlled noises and listening to returns, they could navigate through zero visibility. Modern parking sensors in your car use the exact same principle: ultrasonic echolocation. Vikings were doing it with drums and trained ears instead of speakers and microprocessors. But here's where it gets really sophisticated. Vikings figured out that sound travels faster through warm air than cold. In fog banks where cold and warm air mixed, sound would bend and create acoustic mirages. A cliff might sound closer than it was, or further, so they developed temperature compensation techniques. Feel the air, adjust your sound reading. This is exactly what modern sonar systems do, compensating for temperature and salinity effects on sound propagation. Vikings were doing environmental acoustic modeling in their heads. You're standing in this fog and you can't even see your hand in front of your face. The navigator orders everyone to be silent. He's listening to the ambient noise, the way waves sound against the hull, the pattern of dripping condensation, the distant cries of invisible seabirds. Each sound provides navigation information. Waves breaking means shallow water or obstacles. Seabird colonies indicate specific islands. Even the quality of silence tells you something: deep ocean quiet versus the subtle noise of nearby land. Now for the really mind-bending part. Vikings navigated through fog using smell maps. Different coasts have distinct odors that carry for miles in humid air. Iceland smells like sulfur, Norway smells like pine, Greenland smells like glacial ice, a sharp, clean scent. Scotland smells like peat and heather. In fog, when visual navigation failed, Vikings would literally sniff their way to port. Modern chemical detection systems for autonomous vehicles use the same principle, following chemical gradients to targets. But Vikings took fog navigation even further. They discovered that fog behaves predictably around land masses. Warm land creates updrafts that thin fog. Cold water creates downdrafts that thicken it. By feeling temperature changes and observing fog density variations, they could detect invisible coastlines. This is exactly how modern infrared navigation works in low visibility. Thermal signatures reveal obstacles before you can see them. Vikings were doing thermal imaging with their skin. Here's something that sounds impossible but is documented fact. Vikings could navigate by the sound of the sea itself. Different bodies of water have different acoustic signatures based on salinity, temperature, and biological activity. The Atlantic sounds different than the North Sea. The Arctic Ocean has its own voice. By listening to water noise, not waves but the actual sound of water molecules moving, experienced navigators could identify their approximate location. Modern passive sonar classification systems use the same principle to identify water masses by their acoustic signatures. Let's talk about the Viking navigation technique that modern sailors still can't believe worked: reading the moisture patterns in the air. Vikings discovered that land and sea create different humidity signatures that extend for miles. Land air is drier during the day, more humid at night. Sea air maintains steady moisture. By feeling these humidity gradients on their skin, Vikings could sense land beyond visual range. You're sailing through fog, and the navigator licks his finger and holds it up. He's not checking wind direction, he's measuring evaporation rate. Faster evaporation means drier air, suggesting land proximity. Slower evaporation means humid sea air. This biological hygrometer gave Vikings information about their environment that mechanical instruments wouldn't provide for centuries. Modern weather stations use psychrometers for the same purpose, measuring humidity through evaporation rates. Vikings were doing it with spit. But here's the genius part. Vikings discovered that fog forms in predictable patterns around geographic features. Cold currents meeting warm air create fog walls. Mountains generate banner clouds that extend downwind for miles. Islands create fog shadows, clear areas in their lee. By understanding these patterns, Vikings could use fog as a navigation aid rather than an obstacle. See a fog wall, you've found the Greenland current. Clear patch in widespread fog. There's an island upwind. Now for something that makes meteorologists impressed. Vikings figured out pressure navigation. They noticed that their ears popped at certain locations, not due to altitude but atmospheric pressure changes. High-pressure systems rotate clockwise in the northern hemisphere, creating predictable wind patterns. By tracking pressure changes through ear discomfort and joint aches, Vikings could determine their position relative to weather systems. Modern aircraft altimeters use pressure for elevation. Vikings were using it for horizontal position. You want to know what's absolutely crazy? Vikings navigated by watching fog move, not where it was, but how it flowed. Fog rivers follow underwater valleys. Fog waterfalls cascade over underwater cliffs. Fog spirals mark underwater mountains. By reading fog dynamics, Vikings could map invisible seafloor topography. Modern computational fluid dynamics models do the same thing, using flow patterns to infer boundary conditions. Vikings were doing CFD analysis by eyeball. Here's where Viking fog navigation gets prophetic. They discovered that certain fog types preceded specific weather by predictable intervals. Radiation fog meant calm weather for days. Advection fog preceded storms. Sea smoke indicated Arctic air masses approaching. By identifying fog types, Vikings could predict future conditions and plan routes accordingly. Modern numerical weather prediction models use the same atmospheric indicators. Vikings were doing weather forecasting through fog taxonomy, but the most impressive fog navigation technique was using sound channels. Temperature inversions in fog create acoustic ducts that carry sound for extraordinary distances. Vikings would position ships at different depths in the fog layer to find these channels, then use them for long-range communication and navigation. One ship finding land could signal others miles away through these invisible sound highways. Modern submarine communication uses similar sound channel exploitation. Vikings discovered acoustic waveguides 1,000 years before physics explained them. Alright, this is where Viking navigation gets genuinely supernatural looking, even though it's pure science. Vikings navigated through Arctic winter darkness using ice crystals in the air as fiber optic cables. When ice crystals form in specific conditions, they create light pillars, vertical beams of light that extend from any light source. Vikings used these pillars as navigation beacons, visible for miles in clear Arctic air. Here's how it worked. A fire on shore would create a light pillar visible far beyond the fire itself. Multiple pillars from different settlements created a navigation grid in the sky. By reading pillar positions and intensities, Vikings could triangulate their location in total darkness. This is exactly how modern laser guide stars work for telescope adaptive optics, using artificial light sources as reference points. Vikings were doing atmospheric optical navigation using ice crystals as natural light pipes. But Vikings discovered something even more useful. Sun pillars appear before sunrise and after sunset, extending daylight navigation time in the Arctic. These pillars point directly at the sun's below horizon position, providing directional information when the sun itself is invisible. By tracking pillar movement, Vikings could maintain heading through the long Arctic twilight. Modern polar navigation systems struggle with the same problem, limited sun visibility. Vikings solved it with atmospheric optics. You're standing on deck in the polar night, and the navigator is watching the stars, but not directly. He's watching their reflections in calm water between ice flows. These water mirrors provided stable reference points when ship movement made direct star sighting difficult. By using reflections, Vikings could average out ship motion and get precise celestial fixes. Modern image stabilization algorithms use similar techniques, combining multiple samples to cancel out motion blur. Vikings were doing computational photography with their eyes. Now for the technique that sounds like magic. Vikings navigated by the green ice. Certain algae grow in sea ice, tinting it green. This algae only grows in specific temperature and salinity conditions. Green ice meant you were in the biological mixing zone where Arctic and Atlantic waters meet. Clear ice meant pure Arctic water. Brown ice indicated sediment from nearby land. Vikings were using ice color as a biological and geological navigation marker. Modern satellite multispectral imaging does the same thing, using color to determine composition and origin. Here's where Viking winter navigation gets really clever. They used the aurora borealis as a clock. Aurora displays follow patterns based on solar wind interaction with Earth's magnetosphere. These patterns repeat on roughly 11-year cycles with predictable seasonal variations. By knowing where in the aurora cycle they were, Vikings could predict display intensity and use it for navigation timing. Too early in the season, wait for stronger displays. Too late, navigate by other means. Modern space weather prediction uses the same solar cycle patterns. Drop a comment about the worst weather you've ever driven through. Because Vikings did something that makes modern navigation look easy, they deliberately sailed into storms to use them for navigation. Storm systems rotate predictably. By feeling wind direction changes, Vikings could determine their position relative to the storm center. Sailing into the edge of a storm, then using its rotation to slingshot around obstacles. It's insane dangerous and exactly what modern weather routing systems do, using storm dynamics for optimal routing. Vikings were doing dynamic weather routing, while most of Europe thought storms were divine punishment. We need to talk about the Viking navigation network that makes the internet look simple. The chain of knowledge that connected Greenland to Constantinople. You're in a Viking hall in Iceland, and a trader from Norway is describing a new route to Ireland. He's not using maps. He's encoding navigation instructions in a poem that will be memorized, modified, and transmitted across the entire Viking world without writing anything down. This oral navigation network was basically peer-to-peer file sharing without files. Each navigator held pieces of the complete navigation database in their memory. When navigators met, they'd exchange updates, new currents discovered, hazards identified, seasonal variations noted. This information would propagate through the network, reaching distant ports months or years later. It's exactly how distributed databases work in modern computing. No central server, just nodes sharing information when they connect. But here's the brilliant part. Vikings built error correction into their oral tradition. Important navigation information appeared in multiple stories, songs, and poems. If one version got corrupted through retelling, others preserved accuracy. They used rhyme and rhythm as checksums. If the poem didn't flow right, information was missing or wrong. Modern data transmission uses similar redundancy and error checking. Vikings were doing packet verification with poetry. You're listening to this navigator recite a song about sailing to Vinland, and you realize it's not just a story, it's a compressed navigation manual. Each verse contains specific instructions. Sail west from Greenland for 2 days. When you see birds flying south, follow them. When the water turns green, you're on the continental shelf. The narrative structure makes it memorable, but the details are precise navigation data. It's like encoding GPS coordinates in a Netflix series, entertainment that secretly contains critical information. Now for the really clever part. Vikings used competitive storytelling to verify navigation information. Multiple navigators would tell their versions of the same route. Discrepancies would be debated, tested, and resolved. This peer review process ensured accuracy across the network. Modern Wikipedia works the same way, collaborative editing with community verification. Vikings invented crowdsourced navigation verification without the crowd being in the same place. The social hierarchy of navigation knowledge was sophisticated. Master navigators were walking libraries, holding complete routes in memory. Apprentices learned fragments, gradually building complete pictures. This distributed storage meant no single person's death could destroy critical navigation knowledge. It's exactly how modern distributed systems ensure data persistence, multiple partial copies that can reconstruct the whole. Vikings were doing RAID storage with human brains. But here's what really blows my mind. Vikings encoded navigation updates in real time through their network. A ship discovering a new hazard would compose a warning verse. This verse would spread through the network, reaching other ships before they encountered the danger. It's exactly how modern maritime safety systems work: real-time hazard broadcasting. Vikings were doing AIS and Navtex warnings through song and story. Let's talk about the Viking innovation that Silicon Valley wishes they'd invented: the navigation marketplace. Viking ports weren't just trading goods, they were trading information. Navigators would literally sell route knowledge, seasonal updates, and hazard warnings. This created an economy of navigation data that incentivized accuracy and innovation. You're in a bustling Viking port, and there's a navigator holding court in the market. He's not selling fish or furs, he's selling the knowledge of a new route that cuts 3 days off the journey to Ireland. Buyers test his credibility with questions. Other navigators verify his claims. If his information proves false, his reputation is destroyed and his career is over. This reputation-based system is exactly how modern online marketplaces work. Your Uber rating. Vikings invented that concept for navigation reliability. But here's the genius economic innovation. Vikings created navigation futures markets. A navigator would sell information about ice conditions expected next season based on current observations. Traders would buy this future navigation data to plan expeditions. If predictions proved accurate, the navigator's value increased. If wrong, they'd pay penalties. This is exactly how modern weather derivative markets work: trading financial instruments based on future environmental conditions. The quality control in this system was brutal but effective. False navigation information could kill entire crews, so Vikings developed verification protocols that make modern peer review look casual. New routes required multiple independent confirmations. Seasonal variations needed years of observation. Extraordinary claims demanded extraordinary evidence. This scientific method predates formal science by centuries. Vikings were doing reproducible research without knowing what research was. Now for something that makes venture capitalists excited. Vikings created navigation startups. Young navigators would propose expeditions to discover new routes. Investors would fund ships and crews in exchange for exclusive access to discovered routes for a certain period. It's exactly the same business model as modern tech startups: venture funding for innovation with temporary monopoly on discoveries. The only difference is Vikings were disrupting transportation routes instead of phone apps. Here's where it gets really modern. Vikings developed navigation APIs, standardized ways to exchange route information. Specific phrases meant specific things. When a saga said sail until the mountains sink below the horizon, that was standardized distance measurement. Everyone knew exactly what it meant. These linguistic APIs allowed navigators from different regions to share information efficiently. Modern REST APIs work the same way: standardized communication protocols for data exchange. The network effects were powerful. The more navigators participated in the knowledge network, the more valuable it became for everyone. Each new route discovered increased the value of connected routes. Each hazard identified made all journeys safer. This positive feedback loop drove Viking expansion across the known world. It's the same network effect that makes Google Maps more valuable as more people use it. Vikings discovered Metcalfe's law 1,000 years before computer networks existed. Time for the mind-blowing truth about Viking navigation guilds that operated like medieval tech companies. These weren't just professional associations. They were innovation labs, training centers, and quality control boards rolled into one. Getting into a navigation guild was harder than getting into Harvard, and for good reason. People's lives depended on your skills. You want to become a Viking navigator? First, you need to apprentice for 7 years. Not learning from books. Books don't exist. Learning by doing, sailing every route, experiencing every weather pattern, memorizing thousands of details. It's like training a neural network, except the network is your brain, and the training data is the entire North Atlantic. Modern machine learning requires millions of examples to achieve competence. Viking navigators needed the same scale of experience, accumulated over years, instead of milliseconds. But here's the really clever part. Navigation guilds created standardized testing before standardized testing existed. Apprentice navigators had to demonstrate competence through practical trials, navigate to Iceland and back in winter, find a specific small island in fog, predict weather 3 days out. These weren't written exams, they were life or death demonstrations. It's like getting your pilot's license, if failure meant your entire examining board died with you. The guild system created innovation through competition. Different guilds developed different techniques, jealously guarding trade secrets, while simultaneously trying to poach each other's best navigators. This competitive pressure drove rapid innovation. It's exactly how Silicon Valley works, companies competing for talent while trying to protect intellectual property. Vikings were doing corporate espionage and talent acquisition before corporations existed. Now for the economic genius of navigation guilds. They created navigation insurance. Guild members paid dues that funded rescue expeditions and survivor support. If a navigator's mistake caused losses, the guild would compensate victims. This risk pooling allowed for innovation. Navigators could try new routes knowing failure wouldn't destroy families. It's exactly how modern professional liability insurance works. Vikings invented malpractice insurance for navigators. Here's where guilds get really sophisticated. They created continuing education before universities existed. Master navigators would return from voyages and teach new discoveries to guild members. Seasonal gatherings became knowledge transfer sessions. Older navigators would retire into teaching roles, preserving knowledge across generations. This is exactly how modern professional development works, continuous learning to maintain competence. Vikings were doing CME credits without the credits. But the most impressive guild innovation was navigation notation. While Vikings generally didn't write, navigation guilds developed symbolic systems for recording routes, carved sticks with notches for distances, knotted ropes for directions, painted stones for hazards. These physical tokens encoded navigation data in durable, portable forms. It's exactly like early computer punch cards, physical media encoding digital information. Vikings were doing analog to digital conversion with handicrafts. Comment below if you've ever had to learn something entirely through hands-on experience. Because Viking navigation guilds proved that complex knowledge can be transmitted without writing. They created educational systems that produced navigators capable of crossing oceans using Stone Age technology. Modern educational theory is just rediscovering what Vikings knew. Experiential learning beats theoretical knowledge when stakes are high. Alright. Let's dive into the Viking tech that sounds like pure fantasy but actually worked, the navigation crystals that could see through time. Not literally, but Vikings discovered that certain crystals could reveal where the sun had been hours after it passed. They called them Sunstones, and they're about to blow your mind harder than any science fiction. You're holding a piece of cordierite, also known as Viking's compass. This crystal changes color based on its orientation to polarized light. But here's the insane part. Atmospheric polarization patterns persist for hours after sunset. By reading these lingering patterns, Vikings could determine where the sun had set, even in darkness. It's like having a navigation system that works on historical data. Modern GPS post-processing works the same way, using recorded signals to determine past positions. Vikings were doing retroactive navigation with crystals. But the real magic happens when you combine multiple crystals, Different minerals respond to different wavelengths of polarized light. By using a toolkit of crystals, Vikings could extract multiple data streams from the same sky: calcite for basic sun position, tourmaline for fine angular resolution, cordierite for twilight navigation. It's exactly like how modern GPS receivers use multiple frequency bands: L1 for civilian use, L2 for military precision. Vikings were doing multispectral navigation with rocks. Here's where Viking crystal navigation gets absolutely prophetic. They discovered that crystals could detect magnetic storms before they happened. Certain crystals exhibit piezoelectric properties. They generate electrical signals under pressure. Changes in Earth's magnetic field create pressure waves in the atmosphere that these crystals could detect. Vikings noticed that when their sunstones sang, which was their term for vibrating, storms would follow within days. Modern space weather monitoring uses similar magnetic field perturbation detection. Vikings were doing geomagnetic storm prediction with singing rocks. You're trying to use these crystals, and you discover something disturbing. They work differently for different people. Some navigators could see the polarization patterns clearly. Others saw nothing. Vikings selected navigators partly based on their ability to use sunstones effectively. Modern research suggests this is due to individual variations in macular pigment density in the eye. Some people literally see polarized light better than others. Vikings were selecting for a genetic trait that enhanced crystal navigation ability. Now for the really weird part. Vikings discovered that crystals worked better at certain locations. Specific geological formations enhanced or disrupted crystal navigation. They mapped these crystal fields like modern surveyors map magnetic anomalies. Sail too close to certain iron-rich cliffs, and your sunstone stops working. Pass over underwater crystal formations, and accuracy improves. They were essentially mapping electromagnetic field variations using crystal sensitivity. Modern geological surveys do the same thing with magnetometers. But here's the innovation that makes materials scientists jealous. Vikings learned to modify crystals for enhanced navigation. Heating them in specific ways changed their optical properties. Grinding them to particular shapes optimized light transmission. Combining multiple crystals in layered arrangements created composite navigation tools. They were doing materials engineering without understanding materials science. Modern optical instruments use similar techniques, modified crystals for specific applications. Let's talk about the Viking discovery that quantum physicists are still arguing about: crystals that could navigate through multiple dimensions. Not spatial dimensions, but information dimensions. Vikings found that certain crystal combinations could simultaneously indicate direction, time, weather, and magnetic conditions. One tool, multiple data streams, zero electricity required. You're looking through a complex crystal arrangement that Vikings called a world stone. It's multiple crystals mounted in a wooden frame, each oriented differently. As you rotate it, different crystals activate, showing different patterns. One crystal shows sun position, another indicates magnetic north, a third reveals atmospheric pressure through stress patterns. It's like having GPS, compass, barometer, and clock in one unpowered device. Modern multi-sensor fusion in smartphones does the same thing, combining multiple data sources into unified navigation solution. Vikings did it with rocks and wood. But here's the mind-bending part. Vikings discovered that crystals could store navigation information. Exposure to sunlight at specific angles would create internal stress patterns in certain crystals. These patterns would persist for days, creating a navigation memory. By reading these stress patterns, navigators could determine their historical path. It's exactly like how modern GPS loggers work, recording position history for later analysis. Vikings were doing data logging in crystal lattices. The calibration process for these crystal tools was insane. Vikings would take new crystals on known routes, exposing them to specific conditions to create reference patterns. Like training a machine learning model, but instead of adjusting weights in a neural network, they were creating optical patterns in mineral structures. After enough exposure, the crystal would know certain routes. Modern adaptive optics systems use similar training procedures, calibrating optical elements through repeated exposure to known conditions. Now for something that sounds like magic, but is physics. Vikings discovered that crystals could detect invisible hazards. Subsurface rocks create magnetic anomalies that affect crystal behavior. Underwater currents generate electromagnetic fields that crystals respond to. By watching crystal changes, Vikings could detect dangers before hitting them. Modern mine detection uses similar principles, sensing magnetic anomalies to find hidden objects. Vikings were doing remote sensing with handheld crystals. Here's where crystal navigation gets really sophisticated. Vikings created crystal networks on their ships. Multiple navigators would use different crystals simultaneously, comparing readings to build consensus position. If 3 crystals agreed, the reading was trusted. If one disagreed, they'd investigate why. This voting system ensured accuracy through redundancy. Modern avionics used the same principle, multiple sensors voting on aircraft state. Vikings invented triple redundant navigation systems using rocks. The economic value of navigation crystals was enormous. High-quality sunstones were worth more than gold. Wars were fought over cordite deposits. Trade routes were established specifically to acquire navigation crystals. It created an entire economy around navigation technology. It's exactly like the modern rare earth element market for electronics. Those conflict minerals in your smartphone. Vikings had the same issues with navigation crystals. Time for the Viking crystal technique that modern science is still trying to replicate: biological crystal enhancement. Vikings discovered that certain crystals worked better when combined with organic materials. Wrapping crystals in seal skin changed their optical properties. Coating them with whale oil enhanced polarization sensitivity. They were creating hybrid biological optical devices without understanding optics or biology. You're watching a master navigator prepare his sunstone, and it's like watching a medieval chemistry experiment. He's coating the crystal with a mixture of seal blood and crushed shells, then letting it dry under specific conditions. This organic coating acts as a polarization filter, enhancing the crystal's natural properties. Modern LCD screens use similar organic liquid crystal combinations. Vikings were making organic LEDs without the LED part. But here's the absolutely insane discovery. Vikings found that crystals could be tuned using sound. Specific frequencies would cause crystals to resonate, temporarily changing their optical properties. By singing or drumming at certain pitches, navigators could adjust crystal sensitivity for different conditions. It's acoustic optical coupling that modern photonics engineers are just beginning to explore. Vikings were doing sonically tunable optical navigation. The preservation techniques for navigation crystals were sophisticated. Vikings knew that some crystals degraded over time, losing navigation accuracy, so they developed storage protocols, keeping crystals in specific orientations, protecting them from temperature changes, periodically recharging them with sunlight exposure. It's exactly like maintaining modern optical instruments: regular calibration and careful storage. Vikings were doing preventive maintenance on their navigation tools. Now for the social aspect of crystal navigation. Certain families specialized in crystal preparation, passing down secret techniques through generations. These crystal masters were like modern chip manufacturers, holding critical technology that everyone needed but few could produce. They created artificial scarcity to maintain value, controlling crystal supply to maximize profit. It's exactly the same market dynamics as modern semiconductor manufacturing. Here's where Viking crystal navigation achieved something modern technology struggles with: graceful degradation. As crystals aged or got damaged, they didn't fail completely, they gradually lost accuracy, giving navigators time to adapt or acquire replacements. A cracked sunstone still worked, just less precisely. This gradual failure mode allowed for risk management. Modern electronics typically fail catastrophically. Vikings built better failure modes into their crystal tools. Drop a comment about the oldest piece of technology you still use, because Viking navigation crystals remind us that sometimes ancient solutions are better than modern ones. These crystals required no power, lasted decades with proper care, and worked in conditions that destroy electronics. Your GPS might be more accurate, but it won't work after an EMP or solar flare. Viking crystals would keep working until the sun itself died. That's what I call robust technology. The knowledge transfer around crystal navigation was remarkable. Vikings created crystal libraries, collections of crystals with known properties that apprentice navigators could study. Each crystal was like a book, encoding navigation information in its structure. Breaking a master crystal was like burning a library. Modern seed banks preserve genetic information. Vikings were preserving navigation information in mineral form. Buckle up for the Viking navigation achievement that historians didn't believe until they tried it themselves, sailing to North America without maps, compasses, or even knowing it existed. You're on a ship heading west from Greenland into absolutely nothing. No charts, no destination, just confidence that if you sail far enough, something will be there. This isn't exploration. It's navigation by pure mathematical logic. Vikings figured out something that wouldn't be formally proven until the 1800s. The continents have to be arranged in semi-regular patterns. They noticed that land masses appeared at predictable intervals when sailing east-west at constant latitude. From Norway to Iceland, 600 miles. From Iceland to Greenland, 600 miles. The pattern suggested another landmass, 600 miles west of Greenland. They discovered the mathematical spacing of continental positions through pure observation. But here's the brilliant part. Vikings didn't just randomly sail west. They followed environmental gradients that indicated land beyond the horizon. Water temperature gradually warming suggested a continental shelf. Certain fish species appeared in sequence as you approached coastal waters. Bird migration patterns created invisible highways pointing to land. They weren't discovering America. They were following biological breadcrumbs that said land must be there. You're standing on deck watching the watercolor change from black-blue to green-blue. The navigator gets excited. This color change means you've hit the continental shelf, shallow water extending from an still invisible coastline. But which direction is the coast? Vikings solved this by reading wave refraction patterns. Deep ocean waves hitting shallow water bend in predictable ways. The bend direction indicates where the shallow water is shallowest toward land. It's like the ocean is pointing the way. Now for the navigation technique that sounds impossible. Vikings determined they'd found a new continent, not just another island, by the smell of the rivers. River water from large continents carries distinct organic signatures from vast inland forests. Island rivers smell different, less complex, more oceanic. When Vikings smelled the rich, earthy scent of North American rivers, they knew they'd found something massive. Modern environmental chemistry confirms this. Continental runoff has unique chemical signatures based on drainage basin size. The biological navigation clues were incredible. Vikings noticed that North American birds had different flight patterns than European birds. American birds flew in straighter lines over ocean, suggesting they were traveling shorter distances between lands. European birds flew in curves, optimizing for longer journeys. This behavioral difference indicated that America had different geography, more continuous landmass, less island hopping. Vikings were doing behavioral ecology analysis for navigation. But here's what really demonstrates Viking navigation genius. They found North America multiple times, independently, using different routes. This reproducibility proved their navigation methods worked. It wasn't luck, it was systematic application of environmental navigation principles. Modern science requires reproducible results. Vikings were doing reproducible exploration, proving their navigation theories through repeated success. Let's talk about the Viking navigation calculation that predicted America before finding it. The curvature compensation problem. Vikings noticed that sailing west required constant northern adjustment to maintain latitude. The further west they went, the more they had to aim north to stay on course. They didn't understand spherical geometry, but they observed its effects and compensated accordingly. You're trying to sail due west, but your shadow measurements say you're drifting south. The navigator adjusts course northward, but tomorrow the same thing happens. This is because Earth is a sphere, and maintaining constant compass direction doesn't maintain constant latitude. Vikings discovered this through trial and error, developing correction factors for different distances. Modern Great Circle navigation uses the same corrections, just calculated instead of memorized. Here's the mind-blowing part. Vikings reverse-engineered Earth's size from these navigation corrections. They noticed that the correction amount was proportional to distance traveled. By measuring corrections over known distances, they could extrapolate total Earth circumference. Their estimates were surprisingly accurate, within 10% of actual values. They calculated Earth size using ships and shadows 500 years before Columbus. The seasonal navigation to America was incredibly sophisticated. Vikings discovered that different seasons required different routes due to current and weather patterns. Summer routes followed the warm Erminger current. Winter routes avoided pack ice by sailing further south. Spring routes exploited strong westerlies. They created a seasonal navigation matrix that optimized for safety and speed. Modern weather routing software does the same thing, calculating optimal paths based on seasonal patterns. Now for the navigation discovery that changed everything. Vikings found that North America had different magnetic properties than Europe. Their magnetic navigation tools behaved differently, suggesting the continent had different geological composition. This magnetic signature became a navigation confirmation. When your lodestone acted weird, you knew you'd reached America. Modern paleomagnetic studies confirm that North American rocks have different magnetic properties due to continental drift. Vikings discovered continental magnetic signatures without understanding continents or magnetism. The biological clock navigation to America was remarkable. Vikings timed their voyages to coincide with whale migrations, following the whales like living navigation beacons. Whales know the optimal routes between feeding and breeding grounds, paths refined over millions of years of evolution. By following whales, Vikings were using evolutionary navigation optimization. Modern biometric robotics uses the same principle, copying biological solutions to navigation problems. But here's the really clever bit. Vikings created navigation relay stations across the North Atlantic. Small groups would overwinter at strategic locations, maintaining signal fires and providing waypoints for following ships. These human navigation beacons turned the impossible journey into manageable segments. It's exactly how modern cell tower networks enable long-distance communication, relay stations bridging impossible distances. Time for the Viking navigation evidence that proves they weren't just lucky. They documented their American routes so precisely that modern sailors can still follow them. The Vinland sagas contain navigation instructions that work. Not vague descriptions, but specific, actionable navigation data encoded in narrative form. You're reading these sagas, and hidden between the heroic deeds and family dramas are lines like "sailed before a northeast wind for 2 days until the land sank below the horizon." That's not poetry, that's a precise navigation instruction. Northeast wind in that region averages 15 knots. 2 days equals roughly 700 nautical miles. The land sinking below horizon happens at a specific distance based on elevation. Vikings were encoding mathematical navigation in literature. The landmark descriptions are incredibly accurate. Mountains that look like sleeping giants, fjords that fork like deer antlers, islands arranged like stepping stones. Modern satellite imagery confirms these descriptions match real locations along the North American coast. Vikings were creating verbal maps so accurate that GPS coordinates can be extracted from thousand-year-old stories. But here's the fascinating part. Vikings described American navigation hazards that Europeans wouldn't rediscover for centuries: specific shoals, seasonal ice patterns, dangerous currents. This information was preserved in oral tradition and proved accurate when later explorers encountered the same hazards. It's like having a Yelp review for navigation dangers written 1,000 years ago that's still relevant. The resource mapping encoded in navigation stories was brilliant. Vikings didn't just note where land was, they noted what resources it contained. Forests suitable for ship repair, rivers with salmon runs, areas with wild grapes, giving Vinland its name. This resource navigation meant ships could plan resupply stops, turning impossible journeys into sustainable routes. Modern expedition planning uses the same principle, identifying resource points along routes. Now for the navigation proof that clinches it. Vikings described unique astronomical phenomena visible from North America but not Europe. Specific star positions, unique aurora patterns, different sun angles. These observations could only be made from North American latitudes. They were documenting astronomical navigation markers that proved they were there. Modern archaeoastronomy confirms these observations match North American sky conditions from that period. The climate navigation records are remarkable. Vikings documented the medieval warm period effects on North Atlantic navigation, reduced sea ice, different current patterns, changed wildlife distributions. Their navigation records provide climate data that modern scientists use to understand historical climate change. Those Viking navigation logs, they're now scientific evidence for paleoclimatology. Comment below if you've ever followed directions that turned out to be completely wrong. Because Viking navigation to America proves that accurate navigation transcends technology. They crossed the Atlantic repeatedly using methods that seem primitive but were actually sophisticated environmental algorithms. Your GPS might fail, but the Vikings' method of following whales to America still works. The whales haven't changed their routes. The currents still flow the same way. The stars still point the same direction. Sometimes the old ways are the most reliable. Here we are at the final chapter, where Viking navigation stops being history and starts being the future. You're sitting in a Silicon Valley conference room where engineers are studying thousand-year-old sagas to solve modern navigation problems. Why? Because Vikings solved issues we're just encountering with autonomous vehicles and Mars rovers. The problem modern engineers face is navigation in GPS-denied environments, underground, underwater, on other planets, or after satellite failure. Vikings solved this using environmental navigation that doesn't depend on external signals. Modern researchers are literally recreating Viking techniques using electronic sensors that polarized light navigation. It's being built into drones for polar exploration where magnetic compasses fail. Those biological navigation patterns, they're being coded into submarine autopilots. But here's the real kicker. Vikings solved the resilient navigation problem that military planners obsess over. What happens when your navigation system is attacked? Vikings couldn't be jammed, spoofed, or hacked because their navigation was distributed across multiple independent systems. Sunstones, stars, birds, waves, wind, each system independent but cross-validating. Modern military navigation is moving toward the same model, multiple independent systems that can't all be compromised simultaneously. You want to know what's really wild? NASA is using Viking navigation principles for Mars exploration. Rovers can't use GPS on Mars, so they navigate using visual odometry, sun position, and terrain matching, exactly what Vikings did. The Perseverance rover determines position by comparing terrain to orbital maps, tracks the sun for direction, and uses wheel rotations for distance. It's literally doing Viking navigation with better sensors. The machine learning connection is even crazier. Vikings trained navigators through years of pattern recognition experience. Modern neural networks train the same way, exposure to millions of examples until patterns emerge. Researchers discovered that the way Vikings taught navigation through progressive complexity matches optimal machine learning curricula. Start with simple, clear examples. Gradually add complexity and noise. Test on increasingly difficult scenarios. Vikings invented curriculum learning before computers existed. Now for the innovation that's revolutionizing autonomous shipping. Vikings discovered that environmental navigation is more robust than instrument navigation. Instruments break, environments persist. Modern autonomous ships are being designed with Viking-inspired fallback modes. Primary navigation uses GPS and radar, but when those fail, the ship switches to environmental navigation, reading currents, winds, and biological patterns. It's Viking navigation as backup for satellite navigation. The quantum navigation breakthrough inspired by Vikings is mind-bending. Remember those crystals that use quantum entanglement to detect magnetic fields? Scientists are building quantum navigation systems that work the same way. Quantum sensors that detect gravitational and magnetic anomalies for position determination. No external signals needed. It works underwater, underground, in space. Vikings discovered the principle with crystals. We're implementing it with quantum computers. Let's talk about how Viking navigation is solving the autonomous vehicle problem nobody wants to discuss. What happens when the maps are wrong? Your Tesla's autopilot depends on high-definition maps that assume roads don't change. But roads do change. Construction, accidents, disasters. Vikings never assumed the world was static. They navigated assuming everything could change. Modern sensor fusion in autonomous vehicles is pure Viking thinking. Cameras for visual navigation like Vikings used landmarks. LiDAR for spatial awareness like Vikings used echolocation. Radar for obstacle detection like Vikings used bird behavior. Combine all sensors, trust none completely. This multimodal navigation that Waymo and Cruise are perfecting. Vikings invented the concept using biological sensors instead of electronic ones. But here's the breakthrough that came directly from studying Viking navigation. Researchers discovered that Viking distributed navigation naturally creates blockchain-like verification. Each navigator's observations become a block of navigation data. These blocks are verified against other navigators' blocks. Consensus emerges from independent observations. Modern distributed navigation systems use the same principle. Multiple vehicles share navigation data, creating consensus maps that no single vehicle could generate. It's Viking navigation guilds implemented in software. The environmental prediction models Vikings used are being coded into modern systems. Vikings knew that certain environmental patterns preceded specific conditions by predictable intervals. See these clouds, storm in 3 days. Feel this temperature change. Current shift coming. Modern predictive navigation uses the same temporal pattern matching. Your Google Maps predicting traffic. It's using Viking-style pattern recognition, just with more data points. Now for the innovation that's going to change everything. Biological hybrid navigation. Vikings used animals as navigation sensors. Modern researchers are taking this literally. Cyborg insects with navigation chips that combine biological sensing with electronic processing. Beetles that detect magnetic fields naturally, enhanced with chips that interpret the signals. It's Viking biological navigation with electronic augmentation. The social navigation networks Vikings created are the blueprint for modern crowdsourced navigation. Waze is basically a Viking navigation guild with smartphones. Users share real-time route conditions. Community verifies accuracy. Reputation systems ensure quality. The only difference is speed of information propagation. Vikings took months to share updates. Waze takes milliseconds. But the social structure is identical. Here's the future application that sounds like science fiction. Interstellar navigation can't rely on GPS or even stellar positioning over such vast distances. Researchers are developing navigation systems based on environmental gradients, cosmic ray intensity, dark matter distribution, gravitational waves. These are the interstellar equivalent of Vikings following temperature gradients and bird migrations. The same navigation principles, just scaled up to cosmic distances. As we reach the end of our journey, let's talk about the most important Viking navigation lesson for our digital age: the danger of navigation dependency. Vikings maintained navigation skills even when following experienced guides. Every crew member knew basics. Modern humans can't navigate across their own city without GPS. We've traded capability for convenience. You're probably sitting there with a smartphone that has more navigation power than entire Viking fleets. But can you find north without it? Can you estimate distances? Can you read weather patterns? Vikings would be amazed by our technology and horrified by our helplessness. They built redundant navigation skills into their culture. We've built single points of failure into ours. The resilience lesson is critical. Viking navigation survived societal collapse, climate change, and technological disruption because it was anti-fragile. Stress made it stronger. Each crisis taught new techniques. Each failure improved methods. Modern navigation is fragile, dependent on satellites, power grids, and political stability. One solar flare could cripple global GPS. Vikings navigated through volcanic winters that blocked the sun for months. Their system was harder to use but impossible to destroy. But here's the optimistic part. Viking navigation principles are being embedded into our digital future. Resilient systems with multiple fallbacks. Environmental awareness supplementing electronic sensors. Social networks verifying navigation truth. We're not abandoning Viking wisdom. We're encoding it into silicon and software. The next generation of navigation won't just be more accurate, it'll be more robust, more adaptable, more Viking. The human element remains irreplaceable. Vikings proved that navigation is ultimately about pattern recognition, environmental awareness, and accumulated wisdom. No algorithm can replicate the intuition of an experienced navigator reading subtle environmental cues. Modern aviation still requires human pilots despite autopilot capabilities. Ships still need captains despite GPS. Vikings understood that navigation is as much art as science, requiring human judgment that no crystal or computer can replace. As you click away from this video, probably using GPS to navigate to your next destination, remember the Vikings who crossed oceans using shadows and stones. They didn't have satellites, but they had something equally powerful: deep environmental knowledge and unshakable confidence in their abilities. They proved that humans can navigate anything if they pay attention to the world around them. So here's my challenge to you. Tomorrow try navigating somewhere without GPS. Use the sun for direction. Notice wind patterns. Feel temperature changes. Listen to your environment. You might not cross an ocean, but you'll connect with the same navigation instincts Vikings used to discover continents. Because whether you're using satellites or sunstones, navigation is ultimately about understanding your place in the world and having the courage to explore beyond it. Comment below about your own navigation experiences, GPS fails, or if you think you could have been a Viking navigator. Like this video if you learned something that surprised you. Subscribe if you want more deep dives into how ancient wisdom shapes modern technology. And remember, the Vikings didn't have GPS, but they had something better. They had the confidence to sail into the unknown, knowing they could find their way home using nothing but their wits and the world around them. In an age of digital dependency, that's a superpower worth rediscovering. Until next time, keep exploring, keep questioning, and maybe learn to navigate by something other than that blue line on your phone. Peace out.